Good morning, sir. This is Bhavya Jha from 2nd CSC, and today I'm here to present a presentation on the topic enumerating the number of ways to place 20 distinguishable balls into 5 non-empty boxes. So here's the outline of the entire presentation. On slide 3, we have the problem overview. On slide 4, key combinatorial concepts. Slide 5, approach to the solution. Slide 6 is partitioning balls into non-empty groups. Slide 7 is arrangement in distinct boxes. Slide 8 is final solution. Slide 9 is applications, and slide 10 conclusion. So, the problem overview. Given 20 distinguishable balls and 5 boxes. Objective is to determine the number of ways to place the balls in the boxes such that each box has at least one ball. Constraints are each box must contain at least one ball and all balls and boxes are distinguishable. So moving on to the next slide. Key combinatorial concepts. Distinguishable versus indistinguishable terms. Distinguishable items. Each ball is unique. Each box is unique. Permutation and combinations. Useful for understanding unique arrangements. Stirling numbers of the second kind. Essential for partitioning sets of items into a fixed number of non-empty groups. So moving on to the next slide. Approach to the solution. The solution involves two main steps, that is partitioning and arrangements. So let us understand what partitioning is. So partitioning, finding the number of ways to split 20 balls into 5 non-empty groups. Arrangements, assigning each grouping to one of the 5 boxes, since the boxes are distinguishable. This is calculated using Stirling numbers and factorials. So moving on to the next slide. Partitioning balls into non-empty groups, which is the step 1 of the answer. So to ensure each box is non-empty, we need to split 20 balls into 5 groups using Stirling numbers of the second kind. S of 20, 5 represents the number of ways to partition 20 distinguishable balls into 5 non-empty subsets. Formula is S of n, k is equal to S of n minus 1, k minus 1 plus k into S of n minus 1, k, which is a recursive relation. For this example, S of 20, 5 is equal to 42525. Step 2. Arrangements in distinct boxes. So you can see a diagram over here. This diagram contains certain boxes and there are balls over there. And we partition these balls to segregate them into different boxes. So let's suppose once we have 5 groups, we need to place each group in one of the 5 distinguishable boxes. So let's suppose that we are having 5 groups, and in all those 5 groups we have to place these 5 distinguishable boxes. So for each partition of balls into 5 groups, there are 5 factorial. So 5 factorial is equal to 120. That is 5 into 4 into 3 into 2 into 1. So there are 5 factorial ways to assign these groups to the 5 boxes. Thus, we calculate 5 factorial, which is equal to 120. So moving on to the next slide. What is the final solution? Using the Stirling numbers S of 20, 5 and factoring in the arrangements of for the 5 boxes, total ways is S of 20, 5 into 5 factorial. Substituting in the values, the total ways are 42525 into 120, which is equal to 5103000. So the final answer are there are 51 lakh 3000 ways to place the balls into the boxes. What are the applications? Well, applications include similar counting methods can be applied in data science, inventory management, resource allocation, and distributed computing. So we saw the final answer. Now this concept is very much important because it involves both permutation and combination. And permutation and combinations have wide applications in data science, inventory management, resource allocation. Resource allocation is done even in computer science segment. and distributed computing as well. So what are the next steps is, so this was how we explored about this question, and we understood the importance of permutation and combination. So what is the conclusion? We used combinatorial techniques, that is partitioning and arrangements, to solve the problem, applied the Stirling numbers and factorials to account for distinguishable balls and boxes, and we finally understood the answer as well. So thank you. This was the presentation by Bhavya Jha from the Department of Computer Science and Technology, second year CSE, bearing the roll number 234G1A0525. Thank you, sir.